In the present video, we're going to show you some applications of graphs and statistics calculations using snippets that we indicated in an earlier video, and using the plot XY plugin. For that purpose, we're going to go to a SMS Studio file, and in here we're going to insert the graphics and static snippet. Actually, I should say snippets because I'm going to insert, two of them. So I'm going to click in here and I'm going to say insert, the tools, snippet manager, and we're going to insert the S&GInformation. So I put stats and graphs info. And then we're going to click down below and insert, using Tools Snippet Manager, the S&G functions. So we put stats and graph functions. Okay, the functions include the actual functions that produce the graphics. These are needed in order to utilize specific functions. I was saying that this contains all the functions. I'm going to give you a quick preview of it. And for example, a function to generate a polar grid. If you open that one, you end up with this very long function. If you open this one, for example, it's a shorter function. But there are some that are pretty long, like to generate a color pie chart. It's all programming, and you don't really need to get into these things. You just put it in there and use it. This is informational stuff, and it shows a summary of the function and how the functions are named, what are the parameters you plug in, and what kind of result they give you. So this is kind of the summary of the function names with their application. It comes in two parts, and here you show you how to do a polar plot with grids. So those two snippets are inserted in there, and then you're going to present some examples of plots here. For example, these functions represent a parametric plot where you put the x of t and the y of t, the parameters, beginning value, parameters, ending value, and an increment in t, and then you create a matrix. If you want to see the matrix, you can just say m equal here, and it gives you just a bunch of coordinates that produce the particular plot. I'm going to delete this. And so that's how this parametric plot was produced. A polar grid is generated using the function pgrid. This function has the number of radial distances that are going to be shown, in this case 10, and then, this is the radius of the grid, in the sense that it's centered at the origin, and it has a radius of 10 maximum. And 8 is the number of increments, as you can see, 1, 2, 3, 4, 5, 6, 7, 8, in the radial distance that you're going to be using. This just generates the grid. A polar plot requires you to define a function f of theta, and then use the function pplot, where you specify the function to be plotted, and then the values of the angle theta for which you're going to be plotted, typically from 0 to 2 pi. That produces this pp matrix, which is the polar plot. What I did here, I changed the thickness of the polar plot, which is this 8th figure, to contrast against the polar grid, and then that way you can produce a polar plot by putting together the grid that I call P and the polar plot that I call PP. The polar plot is this one, the grid is this one, and you put them all together, and then you get your polar graphic in one single situation. The statistics, I'm generating here a random matrix that I call R01. I'm going to see if I can show you here what R01 looks like. Just going to put the equal sign in here. Okay, and I'm going to do Control Z, or actually, let's see, oops. Just delete this one. And go to the right and to the right and delete. Oops. Delete. Okay. I'm producing a matrix of 10 by 10 elements, 100 elements, using the function random. So this produces a bunch of random numbers between 0 and 1. With the inverse cumulative distribution function of the normal distribution applied to that matrix, with a mean value of 25 and a standard deviation of 6, I'm producing a series of normally distributed numbers in here with a mean of 25 and a standard deviation of 6. To get an idea what kind of plot I'm going to be using, I get a minimum value and a maximum value of Rn. And then I generate my bins to separate the data into bins between 0 and 50 in elements of 10, which produces this particular bin vector, which we can look at as given by 0, 5, 10, and so on. And then I'm going to, eliminate these. Okay, and then having my data matrix of 100 elements and my bin vector of 10, I can use this function called frequency tx to produce a table of frequencies. And what this is showing is that there are 10 bins starting 0, 5, 5, 10, 10, 15 with mean values 2.5, 75, and so on, and counting 0 frequencies for the first bin, 0 for the second one, 5, 29, 26, 22, and so on. This is the cumulative frequency, which is like the sum of 5 and 29, 34. The relative frequency is divided by the total number of elements, and the cumulative relative frequency also multiplying or divided by the total number of elements. This is something that is commonly done in statistics, and this shows that there is no data below and there is no data above the minimum and maximum values respectively. Now this is basically a brace, and I need to extract this first element, and so I call it T bracket 1, and that extract this matrix. From that matrix, I want to extract my column of frequency, which is the 1, 3rd, 4th, 5th, the first column. So I extract the first column. That's going to be my frequencies, and the bin vector is going to be used with the bar plot f and the bar plot c functions to produce a histogram. Now, every time that I rerun this program by using, for example, recalculate page, you're going to see some changes in the data because the random numbers are different. And so you're going to see that the graphic produced here is going to be slightly different. But it does show that normal tendency of having a lot of frequency in the middle and very little towards the edges. And so this is the application of the function bar plot f and bar plot c. We also are using the X data here to present a pie chart. This is a plain pie chart, and this is a colorful pie chart. Regrettably, 3 of them have 0, so you cannot see anything in there. And then the next one has 12, which is this one right here, and 32, and 32, and 12. These are two of the same size, and 10, and 2, and then the other zeros. And so that's a pie chart. Again, it's not very sophisticated, but it gives you it explains the ability of plot XY to produce those graphics. In statistics, I also have a program called Percentile, taking my data sample, which is the Rn matrix at 10 by 10, to find the 75th percentile, for example, gives me this particular value. The function decile will give me the percentiles 10, 20, 30, 40, and so on. And if I do the old stats Rn, it will give me the mean value, the variance, standard deviation, skewness, kurtosis, the first quartile, second quartile, which is also called the median, the third quartile, the interquartile range, which is the difference between Q3 and Q1, and this minimum maximum value for a box plot they're going to show in a minute, minimum for the whole entire data, maximum for the entire data, and the range is the difference between this and this one. So this kind of describes the sample completely. And then the function box wplot, we produce a box plot like this that shows the median value, the first quartile, the second quartile, and minimum maximum values of the plot. Regarding contour plots, it's basically the function C level that you provide the function f of xy, and then you provide a vector. In this case, this vector k is a range. But to create that range, what I did, I say range from 4 to 24, every 4, so the second one is 8, and so it gives me the values of 4, 8, 12, 16, and so on. And it's giving me the series of implicit plots that will give me the contour plots. Actually, the levels vector, if you type levels control dot, it gives you the functions that are being plotted in there. There are 1, 2, 3, 4, 5, 6 functions that are being implicitly plotted, and that produces the levels. And so this was a brief presentation of the abilities of the functions in the snippets. Again, if you want additional information, go to Stats and Graph Info Snippet, and that will give you more details of what the functions represent and what it's given and what it gets out of them. And then you have a summary of available functions for frequencies and for statistics. And in this instruction on how to produce a polar plot, it simply shows the 2 steps that I did in the examples presented in here. I'm going to close this infograph. And these are the actual functions for which you don't need to worry about them. You just use them as indicated here by invoking the name of the function. With that, we finish this particular video.